Okay, last part for now is part 14, and this is where we see things come together. This is the point of all of this discussion of all the different independent patterns that you can use for resolution. And what obviously we're interested in when we're building applications and application architectures is to create libraries of stuff and build up an application which then is allowed to build up a composite solution out of all of the foundational pieces that we put into different spaces, different libraries. So what we have here is part 14, and part 14 does nothing but import part 5 and part 1. So we're reusing part 1, reusing part 5. Everywhere previously you've seen me either referring to indirect active 1 or active 1. We could have just done it with 2 imports, and we could have reused all of that stuff each time. But we didn't want to do that, just to illustrate the resolution patterns. So what does part 14 look like in the Space Explorer? And if we look at the diagram for part 14, we see part 14 contains a physical endpoint import, and it imports the subrequest accessor, and it also imports the accessor 1 from part 1 where we very first started. So what happens, just to recap, if we ask this part 14 space for active column 1, if we ask to resolve active column 1 in the contextual part 14, we see that it's resolved, and we see the resolution started in part 14. Because there's an import to part 5, it attempted to look in that space first, but it didn't succeed because active 1 doesn't exist in that space. It popped out and then tried the next import, which is the part 1 space. Part 1 space contains an instance of active 1, and it resolved. And so if you request to that, we see we get active 1. Okay, if we equally try and resolve indirect active 1, then no real surprise, something similar. We issue the request into part 14. Over here, the request finds the import delegates the resolution down to this part 5 request space. The resolution is matched by the subrequest accessor, so we found an endpoint that matches. Right, the final part of this then is to try and actually issue the indirect active 1 request and see what happens there. So let's issue that request. Indirect active 1 obviously makes a subrequest to active 1. Let's see how that was issued and requested. What we see is that indirect active 1 was resolved to the subrequest accessor. The subrequest accessor was resolved down, as we saw, into the part 5 address space. So it was resolved down to here. The subrequest accessor then at this point issues a request for active column 1, and that request, active column 1, is then resolved up the superstack. So it's part 5, it doesn't match on there, it descopes to part 14, part 14 doesn't contain it, but now notice we find the import to part 1. Part 1 says I'll delegate your request down again into accessor 1, and lo and behold we get that request. So what we have is the ability for this request, this endpoint here, active column 1, to issue a subrequest for active column 1, for it to go up the superstack, to attempt to be resolved here, to find an import that is able to say I know a space that can attempt to resolve that, and then to call the accessor 1 over here in this space here. So through the spatial relationship and the resolution model in ROC, we're able to have software functions and software capability in 2 independent, completely independent spaces through the nature of the contextual relationship we've created in another address space, be able to interact with one another. And obviously in this case I was using a static hard-coded subrequest, but it could be that using the language runtime pattern or dynamic arguments, that this endpoint can be told to interact with resources from other spaces which it doesn't know anything about. It had no pre-knowledge about these relationships. And one of the consequences of this is we can do some very, very elegant ways of architecting systems together, such that the implementers of any given space can operate on resources that they had no pre-awareness of, and resources that are implemented in special library implementations can be used in applications and reused in applications in multiple different parts of the system. So, for example, another example is if I go and look at part 1 and I see references to the space, then I can see all of the places that this part 1 address space is being used, and it's being used in exactly that same way. It's being contextually associated into different parts of the architecture by different users. Equally, for example, if I go into my modules and I look at the Groovy language, remember we used that as a demo earlier on, and we look for references to Groovy, we can find that these are all the points where Groovy is being used in a space. And so so we can see in, for example, the JavaDoc space. Let's have a look at that diagram and show the libraries. We see over here langgroovy is being pulled in to this import space over here, and presumably this is going to call active Groovy, and Groovy will then call XRL and system services and layer 1 and some local implementation of documentation functions here, and it was completely isolated and had no need or prior knowledge of those resources that it's being told to interact with. And then if you want the final picture of all of this stuff, if we look at Space Explorer and we look at Fulcrum, and I look at, for example, the backend Fulcrum, get a diagram of that, and I show all the libraries. I show the depth as all. This is a very big diagram because the backend Fulcrum is all of these tools that we're using. So what I'm doing is getting a visual representation of the import and resolution relationships between all the independent spaces in the system. And what we have at the very smallest resolution. Here we go. Now we can see it a bit more clearly. We've lost all the detail, but what we've got is structure. We can see the fine structure of our system. We can see there's some kind of front end HTTP layer here, and then there's various overlays, mappings, import points. We see that there's lots of different applications being pulled in into this address space. We can see down here that there's quite an interesting application architecture here. We can see common libraries being used in the back end, so there's probably Groovy being pulled in to various different places. And what we're seeing is this contextual association, such that a space like this can allow the local import relationships and the local resolution patterns to determine what the nature of the operations that can go on in that space are. Equally, I can have some space over here, and yet we can merge this software dynamically on the fly to create what is effectively a web of webs. Remember, every single one of these address spaces that you see in the diagram is behaving exactly like a miniature micro-sized World Wide Web. And this is what happens when you start to allow the resolution process to not just be localized like it is with the DNS in the World Wide Web, but to be contextually localized and delegated so that webs can have knowledge about other webs, and we can build up our architecture from those primitive building blocks.